try this again. Chapter 2.4, adding and subtracting polynomials. So by the end of this class, you should be able to add and subtract polynomials. We looked at the other day some polynomials, and maybe something like this. Okay, so that has two terms, right? If you have something like this, maybe that one has how many terms? This one has how many terms? 3, right? Where can you split it? Right? Here and here. So remember, the term always takes the what? The sign in front of the number. Okay, so a monomial, we talked about this. How many terms does a monomial have? 1, so it's one term. Okay, so for example, 3x, what else will be a monomial? X squared, right? Negative 3y. So all those are monomials, one single term. A binomial. Binomial is how many terms? 2, so it's going to be 2 terms. And so this one will have like 3x minus 4, or x squared plus 5, and so on and so forth. Now the next one, it says trinomial, and what is a trinomial? It has 3 terms, and so you get something like, I don't know, 3x squared minus 4x plus 10. So that's something that we don't do too much in this class, but once you get into grade 10, you'll have to graph these and so on. Okay? All right. Are we good? Okay. So, now write this down. We're going to add and subtract apples and bananas. Okay? And hopefully this will kind of help you understand what we have to do. So here I have an apple. And so in this case, let's say I have 1 apple, and then plus 1 apple. Okay. What do you get? 2 apple, right? 2 apples. So this is like 1a plus. 1 what? A. And that should equal to what? 2a. So what is the process? All you have to do is what? Add the numbers, right? Did the letter change in any way? No. You have to remember that. Okay, be sure to remember. So let's try another one. How about if I have 2a plus 3a? What is that? 5a. Okay, so again, all you needed to do is what? Add the numbers and just stick the letter. The letter does not change. Are we paying attention? Okay. Let's try a banana. Okay, so what if I have 3 bananas and I take away 1 banana? What do you get? 2 bananas. Again, all you have to do is what? Add or subtract the what? The numbers. But yeah, yeah, bananas. But then really it still stays what? The same. The letter, the variable still stays the same. Okay, now let's try this one. All right. Let's try 1a, so 1 apple plus 1 banana. Okay, what do you get if you add 1 apple and 1 banana? Yeah, you get 1 apple plus 1 banana. You see, you cannot combine the A and B together because they're different things. You understand? Yes. So you can't add them together because you have an apple and banana. You can smush them together, but you know that might not look so good. Okay. Yeah. Okay. Shh. Now, so again, in order to be able to add the numbers together, they both have to have the what? Same, well, same variable, right? Yeah. It has to have the same what? Variable. So you need to have B and B to be able to add them together. You need to have what? A and A to add them together. If you have A and B, you can't add them together. All you're going to do is just rewrite it. Understand? Very important. Okay, now, what if we have things like this? What is that? I don't know. That's what Google told me when I typed in apple square. Okay, so I have one apple square. Okay, remember, a square is, what do we draw for something that was square? Yeah, a square, right? Something that was squared, like x squared, we did what? We drew a square. So here, 1a squared. So this is my one apple square. Okay, so now let's add plus 2 apple squares. What are you going to get? 3 apple squared. Okay, so again, what did we just do? We just what? Added the numbers, but what happened to the variable there? Stay the same. The exponent also what? Stay the same. Is that okay? I don't think you want me to call out your name on the video. Okay, listen up. Okay. Now, let's say this. 1 apple plus, okay, 1 apple squared. So, what are you going to get now? 1 apple squared with more apple on top or something, right? Yeah, so you're going to get 1 apple plus 1 apple squared. So they did have the same what? Same letter, but what's different about them? Yeah, one is to the power of 1 and the other one was to the power of 2. So the exponent is different. So you can add the numbers if you have what? The same letters to the same power exponent. Did you get that? Yes? All right, so make sure you understand that concept. All right, so let's make that note. Okay? Only add. You can only add. So you can only add or subtract. Okay. Now I'm going to call it like stuff, right? Apples with apples, like things, right? Bananas with other bananas, like. Okay? Apples with apple squares with other apple squares, like. Okay, so like terms. So let's define what like terms are. Please, you need to study the words, right? I mean, it's going to come up on the test. I'm going to ask you what like terms are. You better know what they are, right? So you better make sure you understand and be able to define like terms. So what are like terms? We talked about it already. Has to be what? The variable has to have the what? So terms with same variable or letter. Okay? I'm going to put variable down here. To the same exponent. You understand? So you can only add like terms. Okay, let's continue. Let's try a couple examples. Groups of like terms. So let's try A. All right, what's like 5? What's like -5? What's like this one? What would be another example like this one? like term with this one? 2. Okay, very good. What else? 3. Okay, good. What else? 7. Okay, good. You understand? So those are like. Can we put, let's put another one. 2.5? Yeah, that's like 2. Just numbers. What do we just call numbers? No. What do we just call numbers with no variable? They're not changing. So what do we call them? Constants. Okay, so these are all constants. All right. Oh, let me add another one. 5 squared. Is that like term? Yeah, it is. Because 5 squared is what? 25. 25 is a what? Constant. They're all constants. You got it? So, look, like terms. What did it say? Terms with the what? Same what? Letter. To the same what? Exponent. Does this one have a letter? No. You understand? Okay. Let's continue. So what's like x? Yeah, 2x. What's another one? 3x. 5.5x. Yeah, sure. Okay. And so on and so forth. So those are like. Okay. What's like y? 2y. Negative 3y. I don't know. That, so on and so forth. D. How about what's like xy? Yeah, 2xy. Or even what? Negative 3yx. That's like 2, right? Because they have exactly the same what? Letter to the same exponents. Is that okay with everyone? Okay. Let me do one more. What's like x squared? 2x squared squared, right? Negative 4x squared, and so on. Is that okay? So you can only add things that are in the like groups. So you cannot add between groups here. You'll just rewrite them all and not touch them. Now, the textbook and some people talk about stuff like algebra tiles. Let's see what it looks like. Okay, it disappeared. That was an old link. Okay, so algebra tiles are basically the drawings we made, right? So, for example, this is what the textbook uses. So just go with this. Okay, so for example, let's say I have 2, the number 2. What can I represent that as? And the book uses little squares, and you can put a 1 here and 1 here. So there you have 2 little boxes, okay? 1, 2. Let's say I have x. What can I represent x as? What did we draw before? A line, right? So I believe the textbook uses like a line sort of, but a little thicker thing. So that would be like x. Okay. And you can put, yeah, there's a question there. You can put pluses if you want, +2, right? This is plus as well. So how about negative 2x? What would you draw? 2 of these guys, right? But both of them are negative. So just put a negative there. Okay. What would you draw for x squared? Yeah, a bigger square. Okay. All right. Okay. So those are algebra tiles. And basically, the idea is, can you add big squares with thin rectangles? Well, it kind of doesn't make sense, right? So they have different shapes, so you can't add them together. Do you understand? All right. So I did that idea with the apples and bananas. You got it? Okay. All right, let's try then some questions. Adding and subtracting polynomials. Remember, we always have to do what? Add and subtract like terms. Okay, so let's try this. Let's try an example here. Yeah, go ahead. What's the answer? Very good. 3x. Okay. Is that okay? 1x plus 2 x's. That gives you 3 x's. Okay. How about plus? Okay, so negative 5x minus 2x. And what would this give you? Negative 7x. Okay. You have 5 negative x's and 2 negative x's. So then altogether you have 7 negative x's. Is that okay? All right. Let's try another one. Okay. Let's take a look at this one. And what I'd like you to do for this one on the test and things like that is try to get rid of the brackets. And I want to ask you, can I simply just get rid of the brackets here? The answer is yes. Okay, why? Because is there anything I am multiplying those brackets with? No. So remember what I said before. Once you do the what? Multiplication, what can you do with brackets? Get rid of them, drop them. Once you do the exponent and there's no other multiplication exponent, you can drop the brackets. So here, are these brackets being multiplied with other things? No. So actually here, in this case, you don't need them. Okay, so I can just simply drop them. I'm going to drop them right now. Okay, 2x squared minus 3x. Okay, now here, plus minus becomes what? Plus minus becomes what? Plus and minus become what? Negative. So it's negative 5x squared. Okay, and then plus become what? Yeah, plus 6x. Now remember, in this case, plus negative. If I drop the bracket, I'll get simply plus negative 5x squared. But remember, plus minus is just what? Minus 5x squared. Okay. Now, some people like to write them together, like terms together, and then add it like that. If I'm really having a hard time, I just like to draw lines. This one with this one. This one with this one. Okay? So if you really, really like, you can move them around, put them together. I just draw the lines and I'm good. Okay? But if you need to, go ahead. So what is this? 2x squared what? Minus 5x squared. What do you get then? Negative 3x squared. And then what's the next number? What's the answer there? Huh? What's the answer for the next one? Quick, the video is getting too long. What's the answer for the next thing? Plus or minus? Plus 3x. Okay, so why is it plus 3x? Well, you have, remember what I said, you always take the sign in front. So it's a negative 3, okay, and plus 6. And negative 3 plus 6 is what? Positive 3. All right? Okay. Please, always look at the sign in front of the number. Okay, a lot of students go like that, and they're like, oh, look at that. There's a 3 and plus 6, and so they put negative what? 9. Well, you can't do that, right? Because the 3 is actually what? Negative. You got it? Make sure you what? Look at the sign in front. Okay. Let's try another one. Okay. Now, remember what I said? I like to do what? Try to drop the brackets. Now, can I drop the brackets? Just simply drop the brackets? And the answer here is no. Unfortunately, you cannot. Okay? Can I drop the first bracket? Yes. Because the first bracket, okay, there's nothing to multiply the first bracket, or there's no exponent outside here as well. Okay, so I can drop the brackets there. Okay, so what does it look like? 3x squared plus 2x. Okay, you have to be careful with this one right here, because I said you always take the sign of what? In front. So what's the sign in front of this bracket? It's a negative. Remember what a negative means. It means what? The opposite. The opposite of what, though? The opposite of the whole bracket. The opposite of the whole entire bracket. So, it's what going to be? What's the opposite of 4x squared? Negative 4x squared. What did I say is the opposite of what? Everything. So it's going to be even the opposite of what? Negative 5x. What's the opposite of negative 5x? Positive 5x. Does that make sense? So that negative applies to everything inside. The positive applies too, but the positive doesn't change anything, does it? So we didn't need to care too much about on the top example. But the negative does change stuff. So you need to apply it to everything inside the bracket. And we'll talk more about that on Monday. Okay? But, okay, so what do you get as the answer then? What do you get as the answer? Negative 1x squared. What else? Plus 7x. Now, do I have to write that like that? No. What can I write this as? Negative x squared plus 7x. Remember, if there's no number in front of the variable, it's a 1. In this case, there's a negative in front of the variable, so it's going to be what? That means it's going to be a negative 1. Is that okay? All right. Let's do one more question. I'll give you one more question, and then we'll call it a day for the lesson. Okay, so try that question and we're done. Let's try this question. So let's try here. Again, I said I like to drop brackets. Can I drop the first brackets? Yes, there's nothing here multiplying here, and there's no exponent there, so I can just simply drop the brackets. Negative 3x squared plus 5x. Can I just drop the brackets in the second one? No, because there's a negative. The negative applies to everything inside. So you're going to get what? Quick, loud. Positive 2x squared. And then what? Negative 3x and positive 4. Okay? Add like terms. So the x squared, so negative 3x squared will add to what? The 2x squared. The 5x will add with what? The negative 3x. So, what do you got? Negative x squared plus 2x. Am I done? No, because there was that lone one there that I didn't change or can't do anything with it. So I do plus 4, and we're done. Understand? Okay.